Good morning, dear students. Welcome to this session on pre-stress concrete. We are talking about Unit 3, loss of pre-stress. Till last session, we have talked about the total 5 losses of stresses, and the last one, sixth one, is loss of pre-stress due to friction. And this one is also will be there only for uh, post-tensioned members only. Okay, so this loss of pre-stress will not be there for pre-tension members. Reason, friction between tendon and any other material like either concrete or no duct material, whatever it is, between the tendon and any other material, there will be friction when the tendon is being pulled in the process of uh, you know, uh, elongation of the tendon or the cable. It is going to have friction with the attached material when the cable is curved. Okay, so the design shall take into consideration all losses in pre-stress uh, that they may occur during tensioning due to friction between the pre-stressing tendons and the surrounding concrete or any other fixture attached to the steel or concrete. That means the duct material that we provide like this. So for straight or moderately curved structures with the curved or straight cables, the value of pre-stressing force at a distance x from tensioning end and acting in the direction of tangent to the curve of the cable shall be calculated as below. There is a formula given for the frictional loss of pre-stress. Okay, so it will be read in terms of the pre-stressing force. The P naught is the force that you are actually applying onto the tendon from the hydraulic jock, and over the distance, say for example at this point or at this point, at this point or at this point, there will be frictional loss. Okay, the force will act opposite to this, and the final force will be less than this p naught that we will see. Okay, so at a distance of x, uh, for example, if you take the horizontal component of the pre-stress px, okay, that will be the uh, force whatever is exactly acting at that point. Okay, so if you consider this point, and this is going to be the tangent is going to be inclined, so we only take the horizontal force px. Alpha is the angle of rotation of p naught with respect to the location where you want the pre-stressing force. Okay, so that is alpha angle, the rotation of pre-stressing force. Okay, right, so this is how it is to be measured. So px is the pre-stressing force that is to be measured. X is the pre-stressing force px. Right, P naught is the pre-stressing force in the pre-stress steel tensioning end acting in the direction of the tangent to the force of the cable. Okay, so that is what is this P naught value. Right, e power mu times alpha plus k times x. Alpha, just like just now I told you, that cumulative angle in the radians through which the tangent to the cable profile has turned between any 2 points under consideration. For example, if this is a cable, say if this is the jacking end, okay, So if you want the total loss of pre-stress, that means this is the location of the end of the cable. So if you are going to extend this and draw a tangent, extend this line. So the angle between these two lines is the alpha. That means the total rotation of this line as it proceed through this line. Okay, so that is how you have to measure alpha. And mu is the coefficient of friction, you know it is very well, and k is the coefficient of wave effect. So what is meant by wave effect? Because the cable is going to be in a duct, and now while you tension the cable, it is going to have some wobble effect, like when you uh, pull the any rope or something. Practically you will be seeing that it is going to have a wave nature of movement. So that is going to have the loss of stress also. So that also is being taken into consideration. Both friction and wave effect will be there in this frictional loss. Okay, so both frictional and as well as wave effect. Okay, so k is the coefficient for wave effect. Now the values of frictional coefficient and the coefficient for wave effect, both are to be read from this is code table 19.5.2.6. And for a different cable type and for different duct material, uh, the value of k and mu are given. Okay, so for bright metals, if you are having a sheet of a duct material is of bright metals, your frictional coefficient is high and frictional loss is high, and even wave effect is high. Whereas galvanized materials having little bit lesser coefficients, lead coated will have lowest value, and uncoated stress relieved strands, this for strand, this for cables, wires in cables. For strands, even for bright metals, higher values. Galvanized material 0.2, little lesser value. Lead coated and corrugated HDPE pipes will have lowest value of losses, friction and wave effect. Okay, so these are the values to be taken straight away from the IS code if they are not given in the problem. Okay, so this is how in a simple way you can measure the frictional loss, means effective pre-stressing force after loss. This is the effective pre-stressing force. So initial value is P naught, and final value is Px. So P naught minus Px is the loss of stress, loss of pre-stressing force. Okay, so that is what is loss of pre-stress will be measured in terms of pre-stressing force. Okay, so we will see one example regarding this. The concrete beam 10 meter span, 100 wide, and 300 deep. Okay, so this 100 and 300 is pre-stressed by three cables. The area of each cable is 200 square, and initial stress in each cable is 1200 Newton per square. Cable 1 is parabolic with eccentricity 50 above centroid and at the supports, and 50 below at the center of span. So the first cable is of having 50 above eccentricity. So this is centroid of concrete. So the first cable is 50 above and 50 below. So this is how it is curved cable, 50 above and 50 below CG line. Okay, right? And the second cable is also parabolic with the 0 at the support, 50 mm below centroid. So second cable is having a 0 eccentricity at the support, 50 mm at the center. Okay, this is how the second cable is. Third cable is straight with 50 mm below centroid. Third cable is of straight 50 mm below this. Okay, right. So this is how the other half is of similar way, so that I am not drawing it. And if the cables are tensioned from one end only, estimate the percentage of loss of stress in each cable due to friction. Assume mu value and k value. Okay, if they are not given, you have to read it from the a table given. Okay, so equation of parabola is given by this you know very well, 4 times 4 hx by L square into L minus x. This we have used extensively in case of cables and arches. Okay, so where h I am replacing with e eccentricity, 4ex by L square into L minus x. So just to get the slope value, dy by dx, do dy by dx for this, differentiate this with respect to y. So 4e by L square and L minus 2x, with respect to x you have to do the differentiation. And at x is equal to 0, what is the slope? X0 means it will be just 4e by L is the slope. So slope at the end is 4 times E means eccentricity total with respect to center, it is 100, right? 50 above and 50 below. So when compared to this, total is 100. So this is centimeters, 10 centimeters. Even you go with 100 mm also, no problem. Okay, 10 meters converted to mm, 1000. That also is possible. So 0.04. Okay, so 4 times E by L is the formula. 4E by L. 4 times E is 100, L is 10 meters converted. And cumulative angle between tangents means it is to the center you have measured. Okay, the other half is having the same angle, so 2 times 0.04. Okay, so we measured only from center to the support, so the other end is also there. As I told you that the angle, the total angle should be uh, twice. This is half angle and the other half angle. Okay, if it is only to the center, it will be alpha by 2, double the value. So you have to use 2 times this 0.04 slope at the end. So this is total cumulative angle between the tangents. Cable 2, 4 times E is only 50 mm because support 0, center 50, and 10 meters, this is 0.02. Again cumulative angle is 2 times, both half of the cable you have calculated for this. Full cable 0.04 radians. Now substitute all these values into this. So Px is P naught e power minus mu alpha plus Kx. So where for small values of mu alpha into Kx, you can write it, no, you can expand this e power x form. So P naught into 1 minus mu alpha plus Kx. So Px is equal to P naught minus P naught into, if you send P naught inside, that mu alpha plus Kx, right? So P naught minus Px is the last value. So bring this to this side and bring this to other side. So that is loss of stress is equal to P naught into mu alpha plus Kx. So P naught into mu times alpha plus k times x. Okay, mu value given, alpha is found, k X is the length of the cable, 10 meters. So for cable 1, this is the loss value. For cable 2, P naught mu alpha Kx. This is the loss. Cable 3, there won't be any alpha value because cable is straight, no angle. So alpha is 0. So mu times alpha 0. K into X will be there. Wobble effect will be there. I mean wave effect will be there. So that is this one. So P naught means initial stress. So substitute for P naught, you get all these loss of stress values. And this divided by 1200 is the percentage. And 51.6 divided by 1200 is the 4.3 percent, 2.9 percent, and 1.5 percent. Okay, that is how uh, we are able to find the frictional loss. So finally, the formula that you have to see is that the this is P naught minus Px is equal to, okay, this loss of pre-stress means P naught is the original where the reading in the hydraulic job minus the Px is the actual value after frictional loss. So loss will be P naught minus Px. So P naught into mu alpha plus Kx is the simple formula to be used, and you have to find alpha angle from this parabolic equation, and K and mu values will be given to you. X substitute for the length of the cable, 10 meters. Okay, this is how we go for the loss of pre-stress calculation with friction. Okay, right. So 19.5.6, you have to just go and have a look at it. 19 point, the table that you have seen will be, if you go through that, just to make you comfortable with the IS code clauses, I'll just show you the clause 19.5.2.6. Okay, so this is loss of stress due to friction that is given to you, and this is a table that I was presenting to you. Okay, so K values, if you are having strand, if this information is given to you, it is of lead coated, is used, use this value of 0.03 and 0.18. Okay, so that way you can use all that values, exact values from the IS code. So this is the formula which is available in the IS code also. No need to remember everything. Just go for the IS code. Use this IS code for all the formula and tabular values. Right. Okay. Thank you. We'll talk about much about this in the next session.